Okay, let's take a look at 53. We got W is the weight of a stack of papers at time t, and if you throw a match into the stack, W is going to represent the weight as it burns. So we've got something like this. If this is time and this is the weight, we're going to start out with the initial amount of weight of papers, and then as it burns, the weight's going to go down. And it's going to go down like this, and it's just going to kind of taper off because we're always going to have some ashes in there, so it's probably going to do something like that. Now, do we know it's curved like that? Could it burn like this? Yeah, or it could burn linear. Yeah, I don't know exactly how it's going to burn, but we do know that the weight is going to go down as it burns. So what's the sign of dW dt? Well, dW dt is the rate of change of the weight of the burning paper. Okay, so what's happening? Well, the weight is getting smaller and smaller, so the rate of change is going to be negative. It's going to be something like negative 0.5 pound per minute, or negative 1 pound per minute, depending on how fast the fire is burning, right? Because for every minute, it's going to be going down half a pound. Or for every minute, it's going to be going down a pound, right? Negative 1 pound. So the rate's going to be negative. Another way to look at it is the rate of change is the slope of the tangent line. And the slope of the tangent line is, of course, negative as you look at it. So there's A. B. What behavior of dW dt indicates there's no longer any fire burning? Well, if there's no fire burning, the weight is not changing, so that means it's going to be 0. Suppose you have a fire going, you start the fire, and the weight's going down, and then all of a sudden the fire goes out. Then it's just going to be straight across because the weight won't change when there's no fire burning. And if you're going straight across, the derivative is 0. C. Fire starts small but increases in vigor, okay, over some interval. So say it starts small, so it's going to burn just a little bit, and then it increases with vigor. Okay. What happens to dW dt? Does it increase or decrease? Well, dW dt, here it's pretty small, negative 0.1 pound per minute. Over here, it's going to be something bigger. I'm just making these numbers up to talk about it, like negative 1 pound per minute. So what's happening to the rate that it's going down? Well, it's actually increasing in the negative direction. So we say that it's decreasing because it's getting smaller, because this number is smaller than this number because it's more negative. So we say dW dt is decreasing. Now we also know what that means is that means the second derivative, we write d squared w dt squared. The second derivative is negative. They didn't ask that, but that is a true statement about this. Okay, and negative means it's concave down, so it all agrees. Now, what about this? The last question is absolute value. What's happening to the absolute value of dW dt? Well, that number is increasing because it's going from positive 0.1 to positive 1. Okay, there you have it.